Question 1. So the value of A is 300,000. B is worth 9,000. C is worth 1,000th because it's a decimal number. So you could have either written it like I have, or maybe you wrote it as a fraction, or maybe you wrote it as 0.001. Okay, this would be the value of it, but I would accept either of the other answers. On to number 2 then, rounding. So question 2A, so we had 64, so the units is a 4, so that means it stays the same, so it would be 60. B, we've got 101.8. Now if we round to nearest 10, it's the units we look at, so we ignore that 8, and that 8 is irrelevant, okay? It's the 1 that we're looking at, because it's a 1, we stay at the same 10, so it would be to 100. C, we've got 5,320,290. It's already on a multiple of 10, so it just stays exactly the same. Okay, it has in effect already been rounded. Okay, so it stays exactly as it is. Question 3. 345.2 subtract 23.85. Now hopefully you should have written it out as a column subtraction like I have. You should have put your decimal points lined up, and because it's 23, that should be under the 45, so the 3 should be on its own. Now subtraction, so we need to put in a placeholder, so we need a 0 above that 5. If you want to put a 0 under the 3, you can as well, but you don't need to do that one. You must do this 0 here. Okay, then we put our equal sign, decimal point, okay, always stays in the same place. So 0 take away 5, we can't do that one, so we're going to go next door to the tenths. So the 2 becomes a 1, and we pass that one on. So it's now 10 subtract 5, which is 5. 1 subtract 8, again I can't do, so I'm going to have to borrow from the ones. So the 5 becomes a 4, we pass 10 on, so it's now 11 subtract 8, which is 3. 4 subtract 3 is 1. 4 subtract 2 is 2. 3 subtract 0 is 3. So it leaves you as an answer of 321.35. Question 4 is 5,673 multiplied by 23. So you should have set it out like that. So we've got some column multiplication. And then we start with the ones in the 2-digit number, okay? And we do ones times the ones. So 3 times 3, which is 9. Then 3 times 7, which is 21, carry the 2. 3 times 6 is 18, add that 2 is 20, so a 0 and carry a 2. Then 3 times 5 is 15, add that 2 is 17, carry the 1. Nothing else there, so our 1 goes up there. So our top line should be 17,019. Then if you just cross those carries out so you don't get confused, now we're going to multiply by 20. So to show that we've multiplied by 10, remember to put our placeholder, our 0 there. Okay, so we've now multiplied by 10. But in order to multiply by 20, we now need to multiply each one by 2. So again, we start with the 1. So 2 times 3 is 6. 2 times 7 is 14. Carry that 1. 2 times 6 is 12. Add that 1 is 13. 2 times 5 is 10. Add that 1 is 11. Carry the 1. Again, nothing else, so we put the 1 up there. So you now should have a bottom number of 113,460. Again, cross out those carries so you don't get confused, because now we're going to add those two answers together to get our final answer. Okay, so 9 add 0 is 9. 1 add 6 is 7, 0 add 4 is 4, 7 add 3 is 10, carry a 1, 1 add 1 is 2, add that other 1 is 3, and then 1, because that's all we've got in that one. So it should give you a total of 130,479. Question 5, I'm just going to do up here, I've got a bit more room. So I've got 9,801 divided by 15. So hopefully you did the bus stop method. Okay, so I've set it out, but I'm okay with my 15 times tables, but they're not my best. So I'm going to write out my 15 times table to help me. So 15, 30, 45, 60, 75, 90, 105, 120, 135. Don't need to go any higher than that. So firstly I see how many 15s can I fit into 9? Well, 0. So I put a 0 up there and I carry that 9. So it's now how many can I get into 98? Well, if I look, 90 is the highest I can get, and that's 1, 2, 3, 4, 5, 6. So I've got a 6 there, and I've got 8 left over, because from 90 to the 98, there's 8 left over. So I carry an 8. So this time I see how many 15s can I fit into 80. So I have a look, 75 is the highest I can get, and that's 5. And this time I had 5 left over. From 75 to 80 is 5. I had a remainder of 5, so I carry that. So it's now how many 15s can I fit into 51? 45 is the highest I can get, so that's 3. So I have a total of 653, but I have a remainder because it didn't go exactly because I only got up to 45. So from 45 to 51 is 6, so I'll have a remainder of 6. As a fraction, that would be 653 and 6/15. Dun 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 dun! My amazing maths brain is going off. I look at those two numbers and I think I can simplify them because I know that they are both in the 3 times tables. So 6/15, which would be the same as 2/5, okay? Because I can fit 2 3s into 6 and 5 3s into 15. I can't simplify that anymore, so that's being simple as 4. I also have to do it as a decimal because Miss Smith also asked for it as a decimal because she likes to give me extra work. So I put the decimal point up there and down there. And also at the bottom, I need to fill in 2 zeros. Now I had a remainder of 6, so that's how many I've got left over to carry. So if I put that 6 there, I then need to see how many 15s can I fit into 60. I can fit exactly into this time, and it's 4 exactly, so I don't need to do any more. If you put a 0 on the end, that's fine, but just leave it as 653.4. Question 6. You might have done this mentally, or you might have done a number line. Okay, so 20 subtract 34. So I'm starting on 20. I need to take away 34. Well, if I take 20 away, that takes me to 0. But I've still got 14 left over, so that will take me to negative 14. Okay. And you must have that negative sign, because if you've just put 14, that's incorrect, because 20 take away 34 is not 14, it's negative 14. Oh, on to fractions, our favourites. Okay, so question 7. So I've got 2/3 multiplied by 4/5. Okay, when I'm timesing fractions, I multiply the numerators together. So 2 times 4 is 8. And then I multiply the denominators together. 3 times 5 is 15. I then look and see if I can simplify it. I can't simplify this one, so I leave it as 8 over 15. Okay, question 8 then. So adding fractions this time. So I've got 10 3/4 add 5 and 7/12. So first step, I'm going to add my 2 wholes together. So 10 add 5 gives me 15. Now I need to look at adding these fractions. Now, they have different denominators, okay? One is quarters, one is 12ths. So I need to make sure that they've got the same denominator so that I can add them. Now, if I start with the highest denominator, that's 12. So I see, does 4 fit into 12? And it does. So that's good, because it means I don't need to do anything to this one. And you know how I'm about the lazy life, so that's great. So I need to convert my 3/4 into 12ths. So in order to get from 4 to 12, I had to multiply that by 3. And we know that because I've done that at the bottom, I'm going to have to do the same at the top. So 3 times 3 is 9. Okay, so now I've got 9/12 and 7/12. So now I can add those together. So 9 add 7 is 16. And we know when we're adding fractions, the denominator stays the same. So it's 16 over 12. However, I'm looking at that and I'm thinking that's an improper fraction. Okay, the numerator is bigger than the denominator. That means I can pull it into a mixed number. So how many whole ones can I fit into that? I can fit 1 whole one in, and then I'm going to have 4 left over. So 1 and 4/12. Ding, 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 ding. My brain's going crazy because it's seeing a 4 and a 12, and it knows it can be simplified. You might look at it and think, well, they're both even, so I can divide by 2. But my brain's a little bit ahead of that. It sees they're both in the 4 times table, so I'm just going to divide them straight by 4. So how many 4s can I fit into 4? I can fit 1. How many 4s can I fit into 12? It's 3, so it's 1 1/3. Last thing though, which is the bit that some of you forget, I need to add this to this answer that I had here. So 1 and 1/3 add 15. So 1 add 15 is 16 and 1/3. So it gives me a total of 16 and 1/3. Okay, that's my answer. On to question 9. I had 4/5 divided by 8. Okay, so with this one, I need to see, can I divide my integer, that's my whole number, by that numerator? No, I can't. So I'm going to have to find an equivalent fraction. So I need a number that both my numerator and my integer can go into. Well, they're both going to be able to go into 8. So if I convert that 4/5, so at this time I'm looking at converting the numerator first. So I've times the numerator by 2, so I must do the same to the bottom. So 5 times 2 is going to give me 10. Okay, so now it's 8/10 divided by 8. Well, 8 divided by 8 equals 1, but my denominator stays the same. So it equals 1/10. And then number 10, ooh, BIDMAS. I hope your brain told you BIDMAS. You might have wanted to draw out the little BIDMAS pyramid here. Okay, so we have brackets, then we have indices, so that's times or cubed or power 4, but highly unlikely you'll have to worry about that. Then we have divide and multiply, and then we have add and subtract. Okay, so I've got 5 plus, then bracket 7, subtract 4, bracket, then I've got squared, and then times 10. So brackets, so that's the first thing I do. So 7 subtract 4, that's 3. So I'm going to write the 3 underneath where the brackets are, pull everything else down is exactly as it is. So all the signs, all the other numbers, okay? Next thing that I need to do is indices, and I've got squared, okay, because that's what that little 2 means. Remember, squared means times by itself. So it's not 3 times 2, it's 3 times itself. So 3 times 3, which is 9. So I write that 9 below, and then pull the other bits below. Okay, so now I've got 5 plus 9 times 10. Still got 2 signs left. So I've got an add and a times. In my pyramid, the multiplying comes first. So I need to do 9 times 10, which is 90, then pull the other bit down. Okay, so I've now got 5 plus 90, which equals 95. Okay, so that's my final answer, 95. Hope you got on okay. I'm doing something very similar for you tomorrow.